In the next three examples, we're going to be determining some electron configurations. Now remember, the periodic chart is laid out so that you can determine the electron configuration by just looking at the chart. The first two columns on the chart, 1A and 2A, are for those elements whose last one or two electrons are in an s orbital. The last six columns, 3A through 8A, are for those elements whose last few electrons are in a p orbital. And the middle block, 1B through 10B, are for those elements whose last few electrons are in d orbitals. The rows in the periodic chart represent the energy level of the last few electrons. Row 1 is energy level 1, row 2 is energy level 2, and so forth. That's true for the s orbitals and the p orbitals. For any electrons in d orbitals, the energy level is determined by taking 1 from the row number. So for example, if you look at that first row of d orbitals, that's in row 4 of the periodic chart, but that represents energy level 3. All right, with that information, we can determine the electron configuration of any element on the chart. The first problem in this example asks you to determine the electron configuration of carbon. The way we do this is we simply step through the periodic chart until we arrive at carbon, keeping track of the electrons as we go. The very first square on the periodic chart is hydrogen. It's in row 1, so that means energy level 1, so we put a 1 there. It's in the s orbital block, so its electron is in an s orbital, so we put a little s there. And there's only one electron, so we put a 1 as a superscript. That means one electron. So the electron configuration of hydrogen is 1s1, and that means it has one electron in the 1s orbital. Well, we haven't reached carbon yet, so let's just keep going. The next box is helium. Now remember, helium is usually in group 8A. For purposes of electron configurations, though, we artificially pull it into group 2A. Helium's in the s orbital block, so the electrons that belong to helium are in the s orbital. There are 2 of them, and it's on row 1. So its electron configuration is 1s2, indicating that it has 2 electrons in a 1s orbital. All right, let's keep going. The next stop is lithium. Lithium's also in the s orbital block, so its last electron is in an s orbital, but it's not in a 1s orbital. Lithium's in row 2, so its last electron is in a 2s orbital, so we put 2s1. So lithium's electron configuration is 1s2, its first 2 electrons are in a 1s orbital, 2s1, its last electron is in a 2s orbital. So do you see how this works? Every time I step to another box in the periodic table, I'm adding one more electron. I determine where to add it by the column and the row that the box is in. So let's keep going. The next stop is beryllium. It's in the s orbital block, so its last electron is in an s orbital, and it's in a 2s orbital. So we've got another electron in a 2s orbital, so that means 2s2. The first 2s electron came from lithium, the next one came from beryllium. Let's keep going. Boron. Boron's in the p orbital block, so its last electron is in a p orbital. It's still in row 2, so the energy level is 2, so it has its last electron in a 2p orbital, so we put 2p1 to indicate one electron in a 2p orbital. Finally, we reach carbon. Carbon's also in the p orbital block, so its last electron is in a p orbital. It's still in row 2, so we put 2p2 to indicate we have 2 electrons in a 2p orbital. So that's the final electron configuration of carbon, 1s2, 2s2, 2p2. Now please understand, these electron configurations are very important. Obviously they're important, or the entire periodic chart wouldn't have been laid out to make it possible for you to figure them out. As you'll learn in Module 7, the electron configuration tells you a lot about the chemistry of the atom. Now that's not the only thing it tells you. It also actually tells you where every electron is in the atom. So these electron configurations actually describe the atom. In this electron configuration, for example, this tells us that carbon has a total of 6 electrons. The first 2 are in a spherical orbit close to the nucleus. 1 means first energy level, that's close to the nucleus. S means spherical orbit, and 2 means there are 2 electrons there. Then there are 2 electrons in a bigger spherical orbit. 2 means it's farther away from the nucleus, so it's bigger. S means it's spherical. 2 electrons, means there's 2 electrons there. And then finally, there are 2 more electrons in dumbbell-shaped orbits that are about as far from the nucleus as the second spherical orbit. So these electron configurations look a little arcane, but they're very, very meaningful. All right then, let's work on the next electron configuration. The next electron configuration is that of chlorine. Now think about it for a minute. We don't have to start over here. After all, we determine electron configurations by walking through the chart, box by box. Well, in order to get to chlorine, we've got to pass through carbon. So there's no sense of erasing everything and starting over. Let's just continue on from carbon until we reach chlorine. The next box is that of nitrogen. We add another electron, but it's still a 2p electron because nitrogen is still in row 2 and in the p orbital block. Then the next box is oxygen. We add another electron, but once again, it's a 2p electron because oxygen is still in the row 2, the p orbital block. Then we move on to fluorine. Still in the p orbital block, still in row 2, so that's just another 2p electron. And then we hit neon. Neon's also in row 2, p orbital section, so that adds another 2p electron. We are now up to 2p6. There are 6 electrons in the 2p orbital all the way up to neon. Now we go to the next box, which is sodium. Sodium's on the next row, 3. So its energy level is 3. It's back in the s orbital block, so the electron we're adding here is an s orbital electron. Then we go to magnesium. Magnesium's still in row 3, s orbital block, so the new electron just goes in 3s again, and we have 3s2. The next box belongs to aluminum. It's still in the 3rd row, but it's in the p orbital block, so the next electron we add goes in the 3p orbital. All right, then we continue. We go on to silicon next. It's still in the 3p section, so we just add another 3p electron. And we continue that way. The next box is phosphorus. We add another 3p electron. The next box is sulfur. We add another 3p electron. And then finally we come to chlorine. Chlorine has the 5th box in the 3p row, so its electron configuration ends with 3p5. So this is the electron configuration of chlorine. 1s2, 2s2, 2p6, 3s2, 3p5. Just to make sure you really understand this, we're going to do one more element, silver. Silver's in row 5, column 9b. All right, we have to walk through the chart until we reach silver. Well, there's no sense starting over. After all, if we're going to walk through the chart, we'll reach chlorine before we reach silver. So we might as well take what we've done so far and just add to it. All right, well, the next box along the way to silver is argon. Argon's still in row 3, the p orbital block, so we just add another p electron, and we have 3p6. All right, now we're going to speed up. We want to do this a little more quickly because we have to get all the way down to silver. The next 2 boxes we encounter are in row 4, the s orbital block. That gives us 2 electrons in 4s. So we'll just write that down, 4s2. Then we encounter the d orbital block. Now remember, to get the energy level of the d orbital elements, we have to subtract 1 from the row number. So we're in row 4, but the energy level is 3. They're d orbitals, so we have 3d. We have to go all the way through this block. There are a total of 10 elements there, so that'll give us 10 electrons to throw in the 3d orbitals. So let's just write that, 3d10. All right, we've got to go to the end of the row still. The next set of elements are in row 4, but the p orbital block. So we have to write 4p, and there are 6 of them, so I get 6 electrons in 4p. Now the next 2 elements are in the s orbital block, row 5. So I've got to have 5s2 because there are 2 elements there. Now I'm finally at least in the row and the block that we find silver in. So I've got to walk all the way over to silver. I'm now in row 5, but remember, in the d orbital block, that's energy level 4. So I'm filling 4 d orbitals at this point. In order to get to silver, I've got to walk through 9 boxes. So that's 9 more electrons, so they all go in 4d, and the final section is 4d9. So that's the electron configuration of silver. It's a lot longer, but it's just as important as the other electron configurations we just determined.